So remember what the kind of theme is, that we are doing tricks of integration, and we're doing different rules of integration. And the theme is sort of that every trick of integration, well, some of the tricks of integration are basically the reverse of the tricks of differentiation. Okay. So last time we did use substitution, right? Use substitution, right? And I said that that's actually the reverse of the chain rule, right? So just to reinforce that connection, let me show you, kind of make it even more explicit what I mean. Right? So the chain rule tells you about the differentiation of compositions, right? It says that the derivative of f composed with g is going to be, you know, f prime g of x, g prime x, right? That's what the chain rule says, right? The derivative of this is that, right? Well, if you say that in indefinite integral language, that's the same thing as saying, so that's logically equivalent to, this symbol means like logically equivalent to, right? It implies and is implied by, right? So if I write this, it means that it implies, right? If you write this, it means is implied by, right? So if it implies and is implied by, then it's logically equivalent to. Okay. So okay. So the chain rule says this. That's exactly the same thing as saying that the collection of antiderivatives is just f of g of x plus c. Right? I've written the same thing, exactly the same thing twice. Right? That if you differentiate this, you get this. Right? That's the same thing as saying if you take the antiderivatives of this, you get this. Right? Exactly the same thing. Okay. Just slightly different format. Okay. Right? And what use substitution is basically saying that if we rewrite this as f, if we rewrite this, well, you say, well, look, this is the same thing as the antiderivative of f prime of u du, where u is g of x. Right? Is that clear? Right? If I take the antiderivative of the derivative, I'm going to get f. Right? The antiderivative of the derivative is f of u. Right? So the antiderivative of this is f of u, where u is g of x. So that's the same thing as this. Right? Is that clear? That this is the same thing as this? Right? I hope it's clear. Right? This is the same thing as this. Right? And so what use substitution says is that it's okay to change this thing to this because you're still going to get the same answer. Right? Okay. I don't know if that makes it any clearer. It's sort of the same thing as I did last time. But I hope this sort of makes it clear that there's a relation between use substitution, right? Use substitution is basically switching from this to this. Right? Switching from this to this. And you see that this is the same thing as this, and these are equal via the chain rule. Okay, I don't know that. But anyway, so today we're going to do a really important trick, which is integration by parts. Okay, integration by parts, and this is the opposite of the product rule. So that's what's called the product rule, right? What's the product rule? That the derivative of the product equals, somebody say it to me, equals what? Hunter?
F prime of x g of x plus f of x times g prime of x.
Great. Okay. F prime of g of x plus f times g prime of x, right? Okay. So okay. So there's sort of a habit for people when they're doing the product rule to use u's and v's. So let me just write this with u's and v's. U times v equals u v prime plus u prime v. Okay. Okay. So again, let's rewrite this in the indefinite integral form. Okay. So this says the derivative of this is this, right? So take 5 seconds and write down this in indefinite integral language. Just like what we wrote before about the chain rule. Okay, turn to somebody nearby and show them what you wrote. Yeah, right. So what do I write here? What do I write? The derivative of this is this. In other words, the antiderivatives of this thing are this function plus constants, right? Exactly the same thing, right? These guys are the antiderivatives of that. In other words, the derivatives are those guys, are the integrands. Okay. Okay. So let's rearrange this. So I'm going to write it like this: the integral of u x v of x dx equals u of x v of x minus the integral of u prime x v of x dx. So I just wrote this thing as two. I split this thing into 2 parts, which is okay, because the antiderivative of something plus something is the antiderivatives of this guy plus the antiderivatives of that guy, right? And then I moved one of them to the other side, right? So I moved this guy to the other side. Okay. So this is integration by parts. It says that if you're trying to integrate something that looks like something times the derivative of something, right, then that's the same thing as u times v. So if you're integrating u times v prime, that's the same thing as u times v minus u prime, the integral of u prime times v. Okay. In other words, in some sense, you can shift the derivative to the other function. You can shift the derivative to the other function, but you have to change the sign, and you have to throw in some factor here. Okay, so that's what integration by parts says. That you've got this thing, and it doesn't look like you can integrate it, but maybe you know how to integrate. You know how to integrate it if you shift the derivative onto the other guy. If that's the case, then this is the trick that you want to use. Okay, and so this is the indefinite integral form of it. There's also a definite integral. So this is for indefinite integrals. But there's also a form of it for definite integrals. It's exactly the same thing. You're just taking definite integrals, right? So you evaluate the whole thing between 2 constants, right? So. So just make these guys definite integrals rather than indefinite integrals. Evaluate the thing between 2 constants, A and B. okay, let's see how this works. There's sort of like a notation for it. People sometimes write this as u dv equals uv minus v du. This is just a shorthand, just a shorthand for this. Okay, this is really, I think this is the better way to think about it. But when you're doing the calculations, maybe it's handy to do it that way. Anyway, you see how it is. Right? This is your u dv, uv v du. Okay, let's do an example just to make this concrete. Okay, so I have this thing, the integral. I want to find. You guys, question? No. You want to find the antiderivative of x ln x. Okay, and I say, oh, I don't really know how to do that. So I'm going to think. I'm going to make this guy my. I'm going to make this guy my v prime, and I'm going to make this guy my u. Okay, so my I'm going to take as u. I'm going to have ln x as v. I'm going to have x. I'm sorry, as v prime, I'm going to have x. Or maybe, yeah, let me just think about that. Okay. And so, what is this going to equal? What is this going to equal? Well, u prime is 1 over x, right? And v, if my v prime is x, what's my v prime? Right, x squared over 2, right? And so over here, what I'm going to have, u times v, so I get x squared over 2 natural log x, subtract the integral of u prime times v, right? Right, so that's going to be x over 2. Yes, good.
Is the letter which are defined as u or v prime?
Yes, yes. So we'll see. Let's take a look at that in a second. Okay. So okay. So and then you know what this is. What's the integral of x over 2? What's the integral of x over 2? X squared over 4. Okay. So you get x squared over 2 natural log of x minus x squared over 4 plus 2. Okay. Okay, so that's pretty good because I don't think I at least could look at this thing and know what its antiderivative is, right? I know maybe some of you are smarter. Say, oh yeah, x squared over 2 natural log x minus x squared over 4 plus constant. I know, I can't. So I would say, oh, I don't know what this is, but I'm going to try. You know, I know I can. So I'm going to think of this guy as the v prime, and I'm going to shift its derivative onto the other guy. I'm going to shift its derivative onto the other guy because when I differentiate natural log of x, well, I get 1 over x, and that makes things simpler. Okay. So yeah, normally I write. So when I was in high school, we always wrote this like this. We'd say let u be natural log of x, dv is your x dx. Right? You can write, if you want to write it like this, that's also okay. It's basically the same thing, right? This is the same thing as saying dv dx. V prime is x. It doesn't matter. And then du is going to be 1 over x dx, and then v is x squared over 2. And then you get u times v, right? Minus minus v du. It doesn't matter. But notice that if I had taken my u to be x, so then we asked, what happens if you take your u to be x and your dv to be the other guy? You take your dv to be the other guy. Well then, what's going to happen on the other side? Well, what's du? It's going to be just dx, right? What's going to be v? Well, then you have to integrate natural log, right? Maybe you know the integral of natural log. Maybe you know the integral of natural log, but if you don't, then it's not so simple. Okay, but see, if you do it the opposite way, you get a different answer, right? You'll get something different will happen. Yes, Mira?
I have a question.
Yes.
On the right,
Yeah.
wouldn't it be x squared divided by 2 dx for the integral?
X squared.
Like x squared, because you x over 2 divided by, x divided by 3dx.
Yeah.
Yeah.
So you're saying should this be x squared over 2?
Yeah.
Well, it's going to be, this is going to be v du, right? Right? So I get that my v is the integral, sorry, my v is x squared over 2, my du is 1 over x dx. Right?
Oh, okay.
So I get x over 2 only. Sorry, my contact lens is slipped. Okay. So, okay, let me have you do an exercise. Let me have you try one. This is sort of a funny one. It's this one, natural log of x dx. Okay, so try using integration by parts on this one, and I'll be back in a minute. Turn to somebody nearby and talk with them, please. Mr. You should talk with somebody. Sit up with me. If you want. Please feel comfortable. Okay, so when you're doing the integration by parts, you want to think, I want to break this up into something that I can differentiate and something that I can integrate, right? Right. You want to think of it as there's one part that you're going to be able to integrate, right? That last time we chose this as x. The other part is something you can differentiate. We chose that to be our ln x. Okay. So here we've got ln x dx. What are you going to choose as your u, the thing that you want to differentiate? Ln x. Okay. Well then, what's your v? V prime, excuse me. Yeah, your v prime is 1, right? In other words, your dv is just dx, right? Your v prime is 1. That makes sense? Okay, you choose your v prime as 1. Okay? Okay, So then your du is going to be 1 over x dx. Your v is going to be x. Right? And so what do you get? You get x ln x minus the integral of what? 1 over x times x dx. Right? In other words, dx. Right? What?
Can you explain that one more time?
Sure. Right? So you get, this is going to be, this is your u times v minus v du. Right? So you get v du. Right? V times du, well, this is just 1.
Yeah.
Right? So you get just the integral of, this is 1, so you get minus the integral of dx. Right? The integral of 1. Right? So we get x ln x minus x plus c. Okay. And so that, although, so if you wanted to do it the way that Betty was saying last time, right? Maybe you could. You say, okay, I'm going to take, this is my u and this is my v prime, right? And then you could integrate it. If you knew this, then you could do integration by parts on it with the opposite choice. Okay, if you felt like it.
And where's the x ln x minus x plus c come from again?
That's all of this, right? This is equal to x ln x, and then we've got, right? We've got the integral of 1. Well, the integral of 1 is just x, right? Plus c. Okay, everybody all right? Everybody all right? Any questions? Okay. Okay. X ln x dx. We're going to look at this x ln x again. Suppose we take mu to be x ln x. Okay. We do something similar to what we just did with that one. We take u to be the whole thing. Okay, the whole integrand. And we take our v prime to be 1. Okay. Take 1 minute and see how this goes. You'll see something funny happen. Turn to somebody nearby and talk with them about what's happening. Okay, so what do we get when we differentiate? When we take when we differentiate x ln x, what do you get? You get first guy times the derivative of the second guy, which is 1 over x, plus the first plus the derivative of the first guy times the second guy. Right? By the product rule, right? So you get 1 plus ln x. Right? And then when you integrate this guy, right, you get v equals x, right? Okay, so what are we going to get here? We're going to get uv, right? So we get x squared ln x, right? U times v minus the integral of v times du, right? X plus x ln x dx. Right? Okay. Right. So let me break this up into the integral of x and the integral of x ln x dx. Okay. Right. Well, you know the integral of x. That's just x squared over 2. Right. So if I write this out, I get that this equals x squared ln x minus x squared over 2 plus the integral, minus the integral of x ln x dx. Okay? So you might think, uh-oh, we're in trouble, right? Because we're trying to evaluate the integral of x ln x dx. And maybe if you were crazy, you'd say, okay, now I'm going to use integration by parts on it. And you'd say, okay, I'm going to take u to be x ln x dx, x ln x, and my dv to be dx. And then you go on this way for the rest of your life, right? And then you would die. Okay? But you don't want to do that. So instead, you notice that, look, we got that the integral of x ln x dx equaled x squared ln x minus x squared over 2 minus x ln x dx. Integral of x ln x dx. Right? So you move this guy over to the other side, you get 2 of them, and you divide the whole thing by 2. Right? Okay? So that gives you that the integral is 1/2 of this, right, plus some constant. Which is what we had before. Right? So you take this guy here, you move it over to the other side, you get 2 of them. You get 2 of what we were trying to evaluate. Divide those sides by 2, and you get what we got before. Okay. So this is a reflexive example, right? Something, you flip something back to the other side. And you notice that as long as this number here is not a 1, we're good. Right? As long as, we could have had -3 or, whatever. As long as it's not +1, then we can do the string.
Now, did we get x squared ln x again?
So that is, remember, you got u dv equals uv minus v du. Right? Okay. So this is our u. We chose our u to be this thing. Then our dv is just dx. Right? This guy is u. This guy is dv. If this guy is u, then du turned out to be 1 plus ln x. Right? You differentiate this using the product rule. First guy times the derivative of the second, plus the second guy times the derivative of the first. Right? 1 plus ln x. dv was dx, so v is x. Integrate. If you take the antiderivatives of this, you get v. You get 1. Right? So v equals 6. and then you get b equals x.
Oh, yeah.
And then you just plug in. You say, okay, my integral of u dv is going to be u times v. Well, that's this times this. So you get the x squared ln x. Right? U times v, x squared ln x, minus v du. Right? So v d. I should have put it. Sorry, I should have put in the dx here. So v du. Right? So I get x times 1 plus ln x dx. Okay? So that's you just figure out what u, v, du, and dv are, and then use the formula. Yes.
Can you re-explain the last part?
The last part, yeah. So we did our integration by parts, and we ended up here, right? And it looks like maybe we're out of luck. Okay. But then you remember that we're trying to solve for this thing, right? And here we have negative the thing we're looking for, right? So we've got the thing we're looking for equals some stuff minus the thing we're looking for. Okay? So that means that twice the thing we're looking for is all that stuff. Right? In other words, the thing we're looking for is all that stuff over 2. Other questions? There are other hands up. Okay. Let's do a more complicated example. So using the arc sine. Does anybody remember the derivative of the arc sine? Anybody remember? Yes, Elizabeth.
Is it 1 over the square root of 1 plus x squared?
1 minus x squared. Yes. So 1 over the square root of 1 minus x squared. Okay. So I want you to use that fact to give me an antiderivative of the arc sine. Use the integration by parts plus your known fact to figure out the antiderivative of the arc sine. Okay, turn to somebody nearby and talk with them, please. Okay, so Mr. L, do you have your hand up first?
Oh, no.
No, okay.
Well, I have an answer. But
You have an answer, okay. Go ahead. What do you choose as
What I
you
did
do?
is I let du equal arcsine x,
Sure.
and du equals first dx.
Yes.
So then I got, as you pointed out, 1 over the square root of 1 minus x squared.
And then v is going to be,
Then at this point I'd make substitution like we did in the previous section, I guess.
sure. So you say, okay, so this is going to be u times v
Yeah.
minus the integral of v du, right? So x over, right?
That's what I did.
Yep, okay. And so the only thing we need to do is evaluate this, right? The integral of this. And how do you do that? Use u substitution, right? So take your u to be what? 1 minus x squared, right? Your du is going to be negative 2x dx, right? And so this thing turns into, right, you get u to the negative 1/2, and you get negative 1/2 du. Right? Let me pull the negative 1/2 out. Right? And so you get negative 1/2 u to the positive 1/2 divided by 1/2. The 1/2s cancel out, plus c, right? And so you get negative u to the 1/2 plus c. Okay, by u substitution. Okay, so all together, right? All together, we get the integral of the arcsine is going to be x arcsine minus 1, I'm sorry, plus, because I got minus minus, right? So plus 1 minus x squared to the 1/2 c. Okay, so this is great, right? Integration by parts. I wouldn't be able to tell you the antiderivative of the arcsine just by looking at it. I don't think most people could, but integration by parts makes it easy. So same sort of thing that we did before, just using the arcsine. Okay. Last example. Last exercise. The integral of x to the 5th e to the x cubed dx. Okay. So I'll let you. Yeah, sometimes it's not completely obvious what you should take as your u and your dv. So remember, you want to be able to differentiate the u and integrate the dv, right? So you need to split this up into something that you can integrate and something that you can differentiate. Okay. So you've got 4 minutes. Take 2 of them and see if you can come up with the right thing. Yes.
Since for integration of parts we use the variables u and v.
Yeah, yeah.
Substitution. Do
you also use
u again?
Yeah, so it's a little bit bad. That's kind of sloppy to do it that way. I should probably have used a different letter here, like I don't know, W, because this u is not this u.
Yeah.
Yeah. So yeah.
So w would be another.
It's as long as you keep your head straight, you can still use u as long as you recognize that this is not the same u. Maybe you want to make a cursive u or something. I don't know. Anyway, it's up to you. You can use the. I saw in a Chinese journal they use Chinese characters as symbols, like something of x. Yeah. Yeah. That'd be cool, right? Dragon of X or something like that. Right. not much time left, so let's get started. I want to break this up into something that I can differentiate and then something I can integrate. Okay. With this sort of book problem, you can probably guess that the thing that you can integrate is something a little bit complicated. Right? Can anyone guess what's the sort of most complicated thing out of here that you can integrate? Can you integrate? Of course you can integrate a power of x. That would be too easy, right? You know that that's not going to be the right answer. Can you integrate e to the x cubed? Well, not exactly. You need to put a factor on it, right? You can, as long as you've got the Can you integrate e to the x cubed? Do you have a good, quick antiderivative for e to the x cubed? No, you don't, right? But you can integrate this e to the x cubed if you have an x squared on it, right? Right? Because then you've got e to the u. Well, you've got 1/3 of u prime, right? So you use the chain rule on it. Right? Right? So what do you get when you get this? You get 1/3 e to the x cubed. Right? Okay. So this actually turns out to be the right thing. You take this, you take your dv to be x squared e to the x cubed dx. You take your u to be x cubed. Okay, then du is 3x squared dx. V is just 1/3 e to the x cubed. Right? And you end up with the integral of x to the 5th e to the x cubed dx being u times v, so 1/3 x cubed e to the x cubed minus the integral of v du, right? So you get x squared e to the x cubed dx. Right? For that we can integrate, and we get 1/3 e to the x cubed plus c. Okay. The moral is that sometimes it's not completely obvious what you want to take as your u and your dv, and you have to play around a little bit. Okay. Okay, that's it for today.